Hello dear aspirants, this is Dr. Saurabh Sir's class. We are now solving the TIFR 2024 GS mathematics questions. So this question is our from number theory. So the question is telling us that for a positive integer m, let dm denote the number of divisors of m including 1 and m. Define a sequence an where our n is from 1 to infinity by an is equals to 1 less than equals to m less than n less than equals to n, where our dm is odd, and hashtag means the number of the elements. Okay, so we have to find the limit n tends to infinity an by n. So what can be done in this case? So we are tasked with finding the limit, this, which is our limit n tends to infinity an by n. Okay, so where our an is the number of positive integers, this, and our dm is defined as this. So when our dm is odd, so the number of the divisors of m, dm is odd if and only if when our m is perfect square. The point has to be noted. Okay, so this is because the divisors of m generally pair up unless m is a perfect square. For example, if we take our m as 12, then the divisors of it will be what? Our 1, 2, 3, 4, 6 and 12. So we can take that our 112, there will be 3 and 4, and there will be 2 and 6. Okay, so if we take our m as 16, then what will happen? Then the divisors are 1, 2, 4, 8 and 6. Yeah, odd count, where our 4 is unpaired here. So thus d of m is odd, and if and only if our m is perfect square. We can easily see that. So now we are going to counting the number of perfect square less than equals to n. So the positive perfect square less than equals to n are 1 square, 2 square, 3 square, dot 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 k square, where our k is the largest integer such that our k square is less than equals to, sorry, that will be n. K is the largest integer when our this thing occurs. So that means our k will be this, the greatest integer function used here. So show the number of the integers m such that 1 less than m less than 1 less than equals to m less than equals to n, and our d of m is odd, is an should be this. Yeah. So now we are going to compute the limit which is given in the question, as our question asked us to find this limit an by n. That has to be what? Limit n tends to infinity. Yeah. So as our n tends to infinity, or this thing will approximately be root n. So we can use it here. So our limit n tends to infinity, that would be root n by n. So that would be limit n tends to infinity 1 by root n. So our, as we know that at n tends to infinity, our 1 by root n will go to 0. So our limit n tends to infinity an by n should be 0. So this is the correct option answer of this question. So our correct answer of this question will be 0. Hope you understood, guys. Thank you.